Hello, honors. Happy day. I'm looking at myself, not the camera. We are on the last video of Unit 1. I am thrilled about this. I have to tell you a little bit of a secret. The date today is actually July 30th, 2013. I'm doing these videos in the summer. I've been working on these templates. Couple things. It's really awkward to make videos in your own living room alone. It's really awkward, and you should hopefully know by now. I don't know you yet, but we're far enough into school by the time you're seeing this video, you know that I'm not an awkward person. I am awkward. I'm okay with being awkward, but making videos is awkward. And I've probably already told you this in class, but I do these videos all in the same day. I'll do just a chunk of videos all at once, and I'll upload them right away. But for some reason, I want to give the impression that I don't, so I keep changing my shirt. So that way you think I'm doing them on different days. So right now I'm representing UWEC. That's Eau Claire. That's where my little brother went to college. So, alright, I'm glad I have that off my chest. I'm hopefully getting better at these. But anyway, let's get to the lesson. Alright, our last unit, lesson, Unit 1, Lesson 7, we're going to define and evaluate a function. This might be a longer lesson, but hopefully we'll get through it quickly. So, here we go. Coordinate plane. A lot of you already know this. There are 4 quadrants. They are labeled on your video. Quadrant 1, 2, 3, and 4. They go counterclockwise. Okay? The vertical axis that you see is the y-axis. Okay? The horizontal axis, labeled in blue, is the x-axis. And where the two of them meet, that location is 0, 0. I am very proud of myself for doing that without pointing at the screen, like you can see where I'm pointing. But I just realized that that's a little bit off the screen. That says origin. O-R-I-G-I-N. Probably one of the most misspelled words I come across teaching this class. Okay, so 3, -4 is an example of an ordered pair. The first number, 3, always represents the x-coordinate. The second number, -4, is the y-coordinate. Okay? They always are in the form x, y. Always, always, always. It's never y then x. When we get to slope, sometimes students get this confused. We'll worry about that then. X, y. X, y. I color-coded it too. Alright, so it says plot the following points and determine which quadrant they are in. I am not remembering off the top of my brain if there is a coordinate plane in your notes. If there's not, sketch one. Or grab some graph paper. You know that I keep it in the student corner of my classroom. I probably recommended you grab some. So, the first point. My airliner turned off. Turn you back on. And my airliner disconnected. I'm going to pause and reconnect it. I'm back. That actually took about 15 annoying minutes, but probably 2 seconds when I pause this video. Anyway, let's plot the point 3, 2. 3 is your x-coordinate, so you go 3 to the right on the x-axis. -2 is your y, so you go down 2. Okay? And that's point A. And that's in quadrant 1, 2, 3, 4. That, in Roman numerals, is IV. That's how we label them. Point B, -10. So I go to the left. That's a negative direction on the x. -5. I go -5 on the y, so down 5. And that's point B. And that's in quadrant 3. The point 3, 3 is 3 to the right on the x, 3 up on the y. That's actually point C, and it's in quadrant 1. And lastly, -4, 8. We go to the left 4, and I go up 8. That's point D, and that's in quadrant 2. The quadrants go 1, 2, 3, 4. Moving on. A function. This is the important part of today's lesson. A function is a rule that establishes a relationship between two quantities. It relates two variables. Those quantities are called an input and an output. The collection of input values is the domain. This is also always known as X. The collection of output values is called the range, and that's always known as Y. You can describe a function in 4 ways. An input-output table, explaining it in words, using an equation or a graph. All of these are going to be used throughout your entire mathematical career. An equation and a function. A lot of people use these words interchangeably. There is a huge difference. Okay? A function. For every input, there is exactly one output. Pause this video and write that down in big, bold letters. Every input has exactly one output. So every time you put in an X, you better get the exact same Y. For example, decide whether or not the following input-output tables are functions. Now we can use arrows. Here, my input is a 1, my output's a 4. Think of it as a giant machine. You go to the function factory, and I take a 1 and I shove it into the machine, and a 4 pops out. Awesome. I plug in a 2, and an 8 pops out. I plug in a 3, and I get a 12. I plug in a 4 and I get a 16. At this point, I'm not concerned with how I get the outputs, but that I have exactly those 4 arrows. This is a function. Now the second one, I put in a 5 and a 1 popped out. Now I put in a 5 again for funsies, and a 2 popped out, and I go yell at the function factory salesman, this is not a function. Every input has to have exactly one output. When I input a 5, I better get the same thing come out every single time. Now the third one, my input was a 1, I got a 5. I had an input of a 2 and I got a 6. I put in a 2 again because I'm not letting that factory man give me a broken machine again, and I get a 7. And I say, no thank you, factory man. This is also not a function. Now here we create an input-output table for the function y equals 3x plus 7. Now I'm not going to go through all of the arithmetic on here, but essentially we have said the input is x, the output is y. So I'm going to start by plugging -2 in for x. So we get y equals 3 times -2 plus 7. 3 times -2 is -6 plus 7 is 1. My input is x. It's also my domain. It's also the independent variable. All of those describe the same thing. When I put in a -1, right, I get -3 plus 7 is 4. Put in a 0 and I get 7. Put in a 1 and I'll get 10. And if I put in a 2, I'll get 13. Graphing the function. I pull my... I believe your workbook has graphs. Maybe. No. I bet your homework does. Sketch it if you can. Okay. To graph the function, you make an input-output table. Some of you have probably taken algebra last year, and you might know how to graph this without an input-output table. Being able to graph with an input-output table is still important, so still use this method. I'm going to use the domain -2, -1, 0, 1, and 2. Again, you plug your values in. Y equals 4 plus 2 times -2. 4 plus 2 times -2 is -4. I get 0. When I plug in -1, I get 4 plus -2 is 2. When I put in a 0, I get 4. When I put in a 1, I get 4 plus 2 is 6. And when I put in a 2, I get 4 plus 4 is 8. If you're having trouble with the arithmetic, stop and pause it, See if you could figure it out. Otherwise, write it down, and we can go over it tomorrow. Don't want to forget. Or today. I don't know when you're all watching these videos. Hopefully before class. Now, this input-output table set up 5 ordered pairs. We have the ordered pair -2, 0. -2, 0 is right there. -1, 2 is right there. 0, 4, 0 on the X, 4 on the Y. 1, 6 is up here, and 2, 8 is there. Now, we're going to deal with continuous and discrete functions later. You don't need to draw a line. Some people like to. If you're going to draw a line, make sure it's straight. Big pet peeve of mine. This function, x squared minus 3, -2, -1, 0, 1, and 2. If you don't want to make the whole table, don't make the whole table. Jump right into ordered pairs. Close, 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 close. Oh, and my commas. Alright, when I plug in a -2, watch this closely. Y equals -2 squared minus 3. -2 squared. -2 times -2 is +4 minus 3 gives me 1. That is the most common mistake, to get a -4 there. When I plug in -1, I get -1 times -1 is 1, minus 3 is -2. 0, I get -3. For 1, I get -2. And for 2, I get +1. As you can see, this one, I get -2, 1. -1, -2, 0, -3, 1, -2, and 2, 1. We could tell this one is symmetric. It's equal on both sides. We could tell by our notes. 1 and 1, -2 and -2, -3. This is quadratic, not linear. We're going to get to that. Our learning target today is a big video. To define and evaluate a function, the #1 thing I want in your brain right now is for a function, every input has to have exactly one output. The other thing I want your brain to realize, input is domain is X. Those are interchangeable. Same thing. Input, domain, X. Start over. Input, domain, X. The other one, output, range, Y. Output, range, Y. Alright, we've done 13 minutes on this video. Hopefully you've learned a lot. Last one of the units. You now have everything you need in order to take the Unit 1 test. It's your job to make sure you are prepared. Rewatch videos if you need to. Look through your notes. Look through your workbooks. Look through your homeworks. Whatever you have to do. I've given you the resources. You come to me for any questions. Okay? And we'll make sure we're ready for the test. But make sure it's your job to know if you are prepared. And if you are not prepared, to come to me about it. Anyway, I will catch you on the flip side.